We're going to look at Riemann sums with equations. So let's just look at a little equation and see what a Riemann sum is. So if we have y equals x squared plus 1, okay, and they're going to give you some interval 0 to 2. So here's my graph. We're not going to usually graph them, but for this first one, I'm going to look at the graph. So we're cutting it off between 0 and 2, okay, and we're estimating the area here, so between the x-axis and the curve. Okay? And we're going to use either rectangles or trapezoids to estimate it. So the first type of estimation that we have is a left-hand sum. Okay? So they're usually going to tell us to break the graph up into a certain amount of intervals. So let's say we're breaking this graph up into 4 intervals. I'm just going to take this area from 0 to 2, break it up into 4 sections. And then for our left-hand sum, you're going to start on the very left side. You're going to go up to the graph. Okay, so that's going to be the height of our first rectangle. And then from here, I would go up to the graph again. That'll be the height of the second rectangle. And then again, go up to the graph. That'll be your third rectangle. And then we're going to go up to the graph, and that'll be our fourth rectangle. So I would find the area of these 4 rectangles, add them all up, and that would give me an approximation of this area under the curve. The second type we have is a right-hand sum. So it's the same process from the left, except for we start on the right. You're going to go all the way up to the graph. So this will be the height of the first rectangle. Okay. Then from here, go up to the graph. That would be the height of the second. So this time we're drawing our rectangles starting from the right-hand side. And then I would add up the area of these 4 rectangles. That would give me the approximation for the right-hand sum. So I can see the left-hand sum, since the heights are all a little bit under, it would be a little bit short. The right-hand sum would be a little bit over, estimation-wise, since they go above. Okay. So if we look at our third type, that's a trapezoid sum. Okay. So what you would do is create little trapezoids. So you would connect these 2 points and create a trapezoid here. So same thing here, I would connect these points and create a trapezoid and so on. And then you would add up the area of those 4 trapezoids. Okay. And usually the easiest way to find the trapezoid is take the left-hand and right-hand sum and find the average of those 2. And then the very last type that we have is a midpoint sum. Okay. So what you do, let me erase all of these. So if we just look at this first little section, so from 0 to 0.5, you're going to go to the middle of that section. You're going to go up to the graph and create that rectangle. So same thing for the next one. You would go here, you would go to the middle and create a rectangle using that point as your height, and then add up those 4 rectangles. Okay. So looking at it from a graph and drawing in all the shapes makes it look a little more complicated than it is. So usually what we're going to do is just work from tables we make from the equation. So if we look at this first one, use 4 subintervals to approximate the area under the curve using right-hand sum, left-hand, midpoint, and trapezoidal approximations. Okay, so we have f of x equals the square root of x over the interval 0 to 8. Okay. So the first thing we need to figure out is how we're going to space these x values. So what you're going to do is always take your interval, subtract it, do the bigger number over the smaller one, and then divide it by how many subintervals. Okay. So we're spacing our x values out by 2. Okay, that's going to be like the width of our rectangles. If I jump back to this previous example, we went from 0 to 2, okay, and we split it into 4 subintervals. So that made the width of each rectangle 0.5. So that's what we just did here. Okay. So what I'm going to do is make a table. And I'm always going to start at this x value, so I'm going to start at 0, and I'm going to add 2 until I get to 8. So I'd have 0, then 2, then 4, then 6, and then I'm going to end at 8. Okay. To get the y values, I'm just plugging the x values into this equation. So square root of 0 is 0. Square root of 2, I'm just going to leave as square root of 2. Square root of 4 is 2. Square root of 6, I'm going to leave as root 6. Same thing, I'm going to leave square root of 8 as root 8. Okay. So what we want to do to find the left-hand sum, okay, remember these are using rectangles. Okay. Well, the area of a rectangle is length times width. Okay. If I look at the spacing here, okay, we spaced them all by 2. That's the width of our rectangles. Okay. The height is going to be the length of the rectangles, the y value. Okay. If I look at these rectangles here, I went up to the graph. That was the y value. Okay, so the y value will always tell you how tall the rectangle is. So to get my left-hand sum, you're just going to do length times width for every single rectangle starting from the left side. Okay. So I would do 2 times 0, that would give me the first one, plus 2 times root 2, that'll give me the second one, then 2 times 2, then 2 times root 6. And we're going to leave the last one out because we're just using 4 subintervals. So for the left-hand side, you just use 4 subintervals starting from the left one. So I would use this one, this one, this one, this one. So you're always going to leave out the one on the right. And then from there, you would just type that in on the calculator, and it's going to give you 11.727 units squared. Then we're going to do the same thing for the right-hand sum, but this time we're going to start on the right. Okay. Now, one thing you can do to make this a little bit easier, since the width is the same on all of them, since it's 2, instead of writing 2 times for each of them, I could just leave the 2 in front and add up those y values. Okay, so if these numbers are all equally spaced, which they're always going to be when we make the table from an equation, you can just put the spacing between the x values out in front and add up your y values. So if I do the right-hand sum, okay, again, I'm just going to put this 2 out in front. Okay, so the number out in front is always the space between your x values. Okay, and this time for the right-hand sum, I'm going to start with the number on the right. So I'm going to start with square root of 8 and work my way down and just use these 4 numbers. So when it's the right-hand sum, you're leaving out the number on the right. Okay. And then type that in on the calculator, and you're going to get 17.384 units squared. And then once you have found the left and right-hand sum, the trapezoid sum is easy. You just take these 2 numbers, so 11.727 and 17.384, add them together, and divide by 2. So your trapezoid approximation is always going to be the average of the left and right. So add those two together, divide by 2. And that makes your trapezoid 14.556 units squared. Okay. Then the last type we have to do is the midpoint. Okay, so for the midpoint ones, you have to create a new table. Okay. Because this time we're not using these x values, we're using the midpoint of them. Okay. So the midpoint of 0 and 2, that's just 1. The midpoint here is going to be 3, then it's going to be 5, and then it's going to be 7. Okay. So again, take these numbers, I'm plugging them into the equation. So square root of 1 is 1, square root of 3 is square root of 3, then we've got square root of 5, square root of 7. So to find the area for the midpoint, okay, these are all the midpoints. Okay, these are the 4 numbers that are the midpoints between each set of numbers. Okay, so we're going to take them all, add them together. Sorry, this is square root of 3 right here. Okay. And then I'm going to take that and multiply it by the space between the x's, which is still 2. Okay. And then type that in, and you're going to get 15.288 units squared.